Hello everyone, today I want to talk about how to build a neural network with Python. Firstly, we want to install IPython in your computer, and you can go to this website and download the appropriate Python version for your computer. And basically, I recommend the Python 3.6 version. And then with this IPython installed in your computer, we can right now can build a neural network for you all by yourself. And firstly, we have to build in this neural network class. We have three functions: the initial function, the train function, and the query functions. And then this is the skeleton of the whole neural network. And I can demonstrate this to you. And okay, we can just copy this part code directly, so it saves time. So how should we write in the definition part? In the initial part, and we have found out that so firstly we have to initiate the neural network. Let's think about how many levels should we need in the neural network, and how many nodes in each neural network, and then the learning rate, which so actually we need to define the 4 parameters of the neural network. In order to save time, I have already write a neural network with levels, and we just copy it directly from this. We have three. We have three. We have four parameters, and then we have to set the number of each input and the learning rate. So we and then we should check out should we miss something, and yes, we need to we miss the heart of the neural network, the weight, because the linking weight is where the learning process happened. So we just use the weight matrix to represent the linking weight. So actually, if we want to build a neural network, we need to tool a weight matrix between each two levels, right? So the input level and the hidden level, the weight between the input level and the hidden level, the size is the hidden node and times by input nodes. And the metric weight of the hidden level and output level, the size of output nodes and times by hidden node. So I think you should understand why the size of the weight matrix is this is related to the loads of in each level. So if you understand this, it's very easy to understand. And actually, because the weight is we should assign the initial value to the weights. So the initial value should be randomly selected. Actually, so we use these functions. We can see how this function works very easily, because this function need a NumPy. So we have to import the NumPy library. the NumPy random save rows. Let me see, 3 by 3. Actually, we can just ignore this, and then we print. Wait. And then very easy to run. Oh, what's the define? Okay, we have to run this, and then we can run this. Yeah, we got it. And then if we times minus 1, you can see that its range is between minus 0.5 to positive 0.5, and actually we use more sophisticated one. We use the normalized normal distribution. Okay, normal distribution is we already use this one. Normal distribution. Actually, we use the normal distribution. Yes, we use this one. Let's see how it works. Or sure it works. It sure works. Then first assume that input load is 3, output load is 3, or you can 3, 4, maybe. Let's show you how that work. Okay, so it's just a random value between 0.5 to positive 0.5. Yeah, yes, in this kind of way is used in this in our neural network. So the rate we have to define the weights of the neural network. So the order is it actually don't that matter, because and then what's next? So before we go into more detail of the neural network, we have let's think about how the neural network works. How a neural network works. In the last class, actually he just a neuron just sum up the inputs and then apply the activation function on the adjusted input and then put up output. So we need a activation function. We define a activation function. So the activation function is defined in this library. So we can we have already write one in this library. We have to import this in the first brand. We will say and then define a active function. So this is active function. So what it looks like? What's this function? Is this active function? So I think this is enough for us to develop a neural network and let's do the query part. What the query part of the neural network do? Let's think about how the signals build forward through the network, and this is the input. In the input level, they just receive the input, and then the input level and the input of the level 2 is adjusted. Is received signals from the nodes with the links between them, and then there's a weight on the links. So they just use the matrix the weight times the dot times dot product dot times the singles of from each input rows, and then here they get the input, and then they apply the active function here to generate the output for the output to the level 3. So it's just this kind. The whole single is built forward the neural network like this way. So this actually is very easy for us to write the codes to represent this kind of process. So this should be like this way. And then it should be input list. Because we need the input list to, yes, we need the input list. So the input, we have to do something for the input, because in this case we use the image function, the set mini set, which we need to do something for the inputs, and then transfer it into the format like the neural network loads. So the input the hidden input is like the dot product of the weight and the inputs, and then we apply the activation on the hidden input to generate the hidden output, and the same thing happen in the level, and same thing happen between the hidden level and the output level. The final input is to the dot product of the matrix, the weight matrix and the hidden output, and the final output is we apply the activation function on the final input, and then we retain the final output. So this is the query. This is the query part. So this query part is easy, and the train part is a little complex than query part, but it's also very easy, because we all know the train part just want to use the inner function to use the inner function to minimize the inner. So we use the gradient descendant approach to minimize the inner of the to find the minimum value of the inner function. And the n function is a function of n is a function of the weight. So we just use this to. So in the train function, we have two parameters. The input list and touch list. Touch list is the desired output we found, and we just make a comparison between these two. And then we can see that the output inner is that the touch minus the final output. Inner is hidden, the hidden level, because we have to back propagation of the inner. So the hidden inner, we have to find the inner here, and we find the hidden inner is like because through the calculation we find out the hidden inner is the weight of matrix. The transporter of the weight dot product with the inner output, the output inners. So it's very easy for us to write this. This is what this code is just represent this formula. And then we use this inner, the output inner, to update the matrix, the weight matrix between the hidden and the output. There's a rate. This is the learning rate. This is where we use the learning rate, and the dot product inner, the output inner dot product with the activation function, which is for the output, which means is the final output, 1 minus final output, and times the transposition of the hidden output. So this is where we use the descendant gradient, we get these formulas. So the sense for the input and the hidden for the input, the sensing, the same process also happen in the input level and the hidden level, the matrix of the input between the input level and the hidden level, and it's very easy. So we just we have already know this. I have already called this, and then we just copy it. So like the input, the touch, and then this is like the query process, which means that the singles feed forward through the neural network, and the output enter is the touch minus final output. We get this final output here, and then we have touch here, and the output enter, and then we use this enter to update the matrix. So this is the class, the whole class we have already completed. So let me just do something on this class. So firstly, we have to build a neural network, because in this case we use the okay, we just use this. We have used the input load, this 784 pixels in the image. We have used it to recognize the high lows. I would like to use 200. Okay, 200 is a little larger, but it's okay. The output load is 10 because we have recognized the number from 0 to 9, and the learning rate is 0.1. It's a little small, and we can set it 0.3 firstly, and then the neural network is like this, and then we create an instance of the neural network. Input load is 784, hidden load is 200, output load is 10, and the network is 0.3. After we build this neural network, we have to train this neural network, right? So we have to train it. How can we train it? So we use the data. We have to use the train set. We have to use the train set to train this neural network. Okay, trained. So because this is the whole set is a little large, so we just use the 100 records. You can download the training set from this website. This is completed training set. This is test set, and this is the 10 record of the 10 records. This is 100 records of the training data set. So we just use the small subset of the complete set to first to test our code before we, because we didn't know whether our code works fine. So we use the small one to test it. And this is the open. I have already downloaded in my computer. So this is the path of the file, and then this is read the whole file into the memory of the computer, and then after finishing the data transforming from the computer to the memory, we close the file. So and then we do a loop for the records in the training data list, all values we just because You have you seen the code? And I can show you the code. What the code looks like. And okay, this is the code look like. It's you can save the page source. Oh, you can save pages, and then you can save the uh set the data in your computer. Okay, so we just split the records into all values. That it become a list or something, and then we just do this kind of thing. Input equals number always equal this. In order to make you have some, and then the touch is this, and the O value 0, the value 0 is 7 is the label of this data, this image. Okay, we can see in order to make you understand, oh, understand what's happening here. So let me show you something. Okay, we input the space right, and I remember that we have to import the manifold here. We let import the manifold, the matrix polar library here, and then we can draw the whole pictures. What? Okay. Okay, this is we import this library. Okay, now everything is set, and I will show you how this code works. Okay, let's get one more and values this one. Values. Let's just put in the O value 0. I think it should be was 1, 0. Okay. Okay, this is the label. O values 1. This should be okay. This is what the 1 looks like. This is the whole data file. And then let me show you what this works. I think it's just make adjustment for this. Okay, so it's make the input between 0.01 to 0.99. It's if you understand what I told you in the last class, it will be very easy to understand. So what's this? This is the touch. Touch is just as a array. I can show you. Okay. Okay, what should touch mean? Touch. And then AIR. Okay, so do you mean why this is what I mean? Okay, this is how this code works. After we training is training. After we training, we can testing. So we can query. We can testing. We need to training, and then we need to training. Have we already finished the training? For records okay. Okay, this is one April training. And then we do the testing to see how the training works, if the training works well or not. We use just the test records. Okay, we training. Okay, we testing. Okay, after training, we have share. We should understand whether the training is good or is the training okay. We have to build a scorecard to record the training, the process, the training to remember what the training works. Okay, this scorecard, and then we can use this to see if the training works or not. So, okay, we got a performance 0.5 because it's a small set, so this kind of performance is quite it's really good. It's acceptable because we just use the 100 records training set and the 10 records training testing set. So let me see. Okay, in the next course, I will tell you more about how this code works. See you next time.